Hi everybody, so this is your review for Summative number 6 in the spring of 2020 in PreCalc, so make sure you're watching the right review for you. This has 4 new sections of scores. We're going to be using our new identities from the trig unit 5.4 and 5.5, and then we're also testing circles and ellipses from the conic section. So let's take a look at some examples, and I'm going to try to go a little fast so that way we can get as many examples done in the shortest amount of time. So 5.4, we're going to be simplifying and verifying identities using the various formulas we have from 5.4 and 5.5. So there's an assignment on 7b and then like a whole bunch of other random practice problems. So the first thing I'm looking at is worksheet number 10 on the back side, and they want you to write this as a single expression. So using your blue formula sheet, or when you're testing the purple formula sheet, you're looking at all those identities. And I'm seeing sine, cosine, cosine, sine. This is the difference formula for sine. This is the sine of a minus b. So that comes out to, I gotta be able to subtract here, guys. 42 minus 17 is 25 degrees, I believe. And that is nothing off the unit circle that I could, evaluate. So I'm done. The next question, I see a sine, cosine plus sine, cosine, which is, remember, cumulative property. This can be flipped around. So sine, cosine, cosine, sine with an addition sign. So methinks we're looking at, this time, the sine of a plus b. And with these guys, if I go to add them together, I should visit my 5th grade style common denominator question, right? This would be, let's see, 2/10 pi plus 5/10 pi. So it'd be 7/10 pi. Again, nothing off the unit circle, so I'm just going to leave that one alone. Now, this next question is a lot more complicated than I think it is on the test. This kind of looks like it's trying to be the 2 sine cosine formula, which condenses down to the double angle for sine. However, this guy right here kind of messes things up. So this is really like 8 times this. So there's a really random like factor of 8 that's in front of the problem. And then I would write down the sine of double my angle. So if I look inside the sine and cosine function, notice that your angle is 3x. So if I were to double that, that would be a 6x. So that was way more complicated than it was supposed to be, and it's definitely not like that on your test. This is what will be on your test. Like there won't be a 16 in front, it'll just be a 2. So sorry about that. That is a little higher level on that one. My bad. All right, here we got a cosine, cosine minus sine, sine. That simplifies down to the cosine of, and cosine's weird, it does the opposite sign, so a plus b. So if I add together my a and b, I get 10y. So this is cosine of 10y. And obviously that doesn't simplify any further, so we be done. All right, so this, let's see, this is on the back of your review, and it's a lot of those same questions. So I have to identify the identity that we're looking at. And I don't really like the way the computer does the text here. This is like the sine of 5x times the cosine of 3x. I wish they had parentheses, but whatever. So we have sine, cosine plus cosine, sine. That condenses down into the sine of a plus b. So for us, that would look like 5x plus 3x, better known as 8x. And that's the type of question that you're going to be seeing on your test. Here we got cosine, cosine plus sine, sine. So that is a cosine, and cosine does the opposite sign, so it's a minus b. Now this particular question, it's a combination of a radian measure and a variable, so you don't have to simplify anything here, oops, but you should be able to write 29 pi over 9, and then minus theta is how that will condense down. Again, I don't really like the font here, so I apologize. This is the sine of negative 2x and times the cosine of 3x. So when I look at my pattern, my formula, this is sine, cosine plus cosine, sine. So it's the same one as up here. This is the sine of a plus b. So if I go to add my a and b together, I got negative 2x plus 3x. So that would be a sine of 1x. And then one more of those. We got cosine, cosine minus sine, sine. This time it's cosine of a plus b. So if I take a and b and I add them together, any order technically, we're looking at a weird algebraic thing, cosine of 7y plus 38. So nice, easy identification. Just be careful that you have the right identity. I guess that's the only thing that you're going to mess up there, right? Just be careful with the signs. So here we're going to be verifying the identities. And remember, when you're verifying identities, you are only working on one side, right? So we have cosine of an addition problem. I'm going to break that baby up into cosine, cosine minus sine, sine. So I got to write small here. Cosine, cosine, and then a minus, and then sine, sine. I wrote too big. All right, so a few of these things we could take off the unit circle. Oops, I didn't really want to do that. All right, so this guy and this guy are evaluations straight off the unit circle. The cosine at pi over 2 is 0. So this whole term is 0. And then you have a subtraction, and then the cosine of 1 is, or sorry, the cosine at pi over 2 is 1. And you're multiplying that by the sine function. So 0 minus sine is negative sine. So there's not a lot to that identity. If I was very good at keeping track of my work, I would have put equals negative sine, and equals negative sine down the right-hand side. Number 2 is very similar. Expand it with the sine of a plus b formula. I'm going to skip ahead for the sake of time, and let's go look at the next section. So now we're going to be solving and evaluating with the sum and difference and half angle and double angle identities. So same identities, but a different use of them. And this question is right on the review on the front. Watch your signs on the test. So you have like a kind of drawn triangle for alpha and for beta. Whether it's Pythagorean theorem or that you have this memorized, this is a Pythagorean triple, so the hypotenuse is a 29, and then this leg would be a 24. So again, Pythagorean theorem or just from memory, that's awesome. So this triangle right here is referring to what they're calling angle alpha. So they're going to want you off to the side to write down all the ratios for alpha. And for sine of alpha, we're looking at 21 over 29. And then the cosine of alpha was negative 20 over 29. And over here, this triangle is referring to the angle beta. So the sine at beta is 7 over 25, and the cosine would be 24 over 25. So what we're going to be really clear about on our test is you're going to write out the identity that you're using to figure out cosine of alpha minus beta. So this identity, straight off my formula sheet, is cosine, cosine plus sine, sine. So if you can't use alphas and betas very easily, just use a's and b's. So cosine, cosine plus sine, sine. And then if you think about what you're doing next, you have the cosine of alpha. You have a ratio for that, right? It's right here, negative 20 over 29. And you're multiplying that by the cosine of beta, which is this guy. And then there's a plus sign between these fractions. And then sine of alpha over here, 21 over 29. And you're multiplying that by the sine of beta, which is 7 over 25. So for me, I crank this entire thing into my calculator. You don't even need parentheses because you're just multiplying by, single fractions like that. And then I, of course, hit math, enter, enter, and I'm pretty sure the answer comes out to negative 333 over 725. But if that's not right, talk amongst yourselves and figure out what dumb thing Abruzzo just did. So these are a little tricky. You just got to be careful you're filling in the right ratio and that you're also using the ratio in placement of all the cosine and sine functions. Sometimes kids do weird things like they have cosine of 20 over 29 on their calculator, which is not at all what we're asking you to do. All right, number 4. This is on worksheet 9. This is a great question getting ready for our test. So we're going to use these new identities. And I'm thinking this guy right here, we have a wonderful trade for sine of 2x. This is the double angle formula. So on your formula sheet, it says like sine of 2 theta is 2 times the sine of theta times the cosine of theta. And if we do this trade, and we're going to use x, of course, instead of theta, when we do this trade, that's going to allow us to solve this question through like factoring. So that's the trade. The rest of the equation exists as it was. And now I see that we all have cosine and sine functions for the value of x, which means I'm allowed to solve it through factoring. Notice everything is set equal to 0, but this expression over here on the left-hand side, there's a common term of cosine. Some of us learned the hard way on the last test that you cannot divide by the cosine function, but you surely can factor it out. So you're left with cosine times the quantity 2 sine x minus 1. And now that we are done factoring, now we're going to set equal to 0 and solve each of the factors. So the first factor is really boring. Cosine equals 0. I'm ready for the unit circle here. This next one takes a little bit of algebra work before you look at the unit circle. So you're going to add 1 and then divide by 2. So you were looking on the unit circle for places where sine equals 1/2. And I believe it does say all solutions up here. I'm going to do the lazy kid method for all solutions. All right, so cosine of 0, that would be at pi over 2 and at 3 pi over 2. And then lazy Abruzzo just says plus 2 pi n on everything. That is surely not the simplest way to write answers. You know, pi over 2 plus pi n is the simplest way, but I don't care. Now there's two places where the sine value is a positive 1/2. That would be your pi over 6 family. So let's see, positive sign would be at pi over 6 and then at 5 pi over 6. So once again, I want all solutions, plus 2 pi n plus 2 pi n. So I have no problem with you guys being lazy like me, obviously. The important part of that question was, did you see the trade? And I hope you did. So this next one, again, we're looking for a trade. And I don't want everyone to get confused with what trade I'm looking at. This is cosine squared minus sine squared, which, don't get that confused with one of your Pythagorean trades. This is the double angle for cosine. So this is cosine of 2 theta is equal to all those 3 different ones. So for us, instead of theta, they're measuring the angle as x. So this is getting traded out for cosine of 2x. And we're going to ask where that equals the square root of 3 over 2. And I think it'd be best right now if we went ahead and used our skill of U substitution. Now my kids, we're a little lazy, and I'm the queen of you, and we don't like to do the U substitution thing because we know we're just going to substitute it right back out again. So instead of saying U equals, we just kind of cut out the middleman and say 2x equals. And we know there's going to be 2 places where the cosine function gives you a positive square root of 3 over 2. And that would be at, let's see, that would be pi over 6 family again, right? So positive, so it's pi over 6, and then 11 pi over 6. Now it did say for all solutions, so regardless of whether it's at all solutions or just between 0 and 2 pi, you still stick a plus 2 pi n right here in your work, not at the end. But then you got to come back and reduce the angle by multiplying by a 1/2. And this is what allows you to give the answers. And again, lazy kid notation works for me. So x equals, this is pi over 12 plus pi n, if I hit all these by 1/2. And then this guy becomes 11 pi over 12 plus pi n. Get out of there. Okay, so yay for lazy people. We're done. All right, so very similar to a question we saw in the last test, but now you have this other trade that you got to think about this week. This question is similar in nature, and it might be a good one for us to look at. This double angle for cosine, don't grab the negative with it though, be careful there. Remember how cosine has a bunch of trades, so you want to be choosy as to which one. This is on the back of your review page. So cosine of 2 theta, I already have a sine squared in my problem. So I'm thinking it would be really brilliant of us if we used the one that says 1 minus 2 sine squared. But you gotta be real careful. There's a negative outside of it, and then there's all the rest of the equation off to the side. Oh, and don't forget the rest of the equation equals 0 over here. So I'm going to distribute the negative to here and here. So that gives us what? Negative 1 plus 2 sine squared theta. We got a minus 6 sine squared theta plus 3. And I know at first glance everyone's thinking, oh, this is a factoring question. I would argue that this is actually going to be a square rooting question because these are like terms and it's the only trig function in the problem. So we're going to be able to square root once we get this isolated. So I'm going to, say this plus 2 gets shifted over by subtracting it over here. Sorry, I skipped a step there. And then right here we got what, a negative 4 sine squared? Okay, so I'm not ready to square it yet. I'm going to divide both sides by negative 4. I'm also a little eked out that this equation's kind of backwards to me, so I'm going to rewrite it as sine squared equals 1/2. And then, oh man, nightmares from the last test. When you guys square root an equation in math, your answers are both positive and negative. So y'all, you got sine of theta equals positive or negative, and then if you square rooted 1/2, think about what happens here. Square root of 1 is 1, but then the square root of 2 gets rationalized, so this is square root of 2/2. So I'm only looking for answers between 0 and 2 pi, and you're supposed to give me all of my pi over 4 family. So we got pi over 4, 3 pi over 4, 5 pi over 4, woo, get away from me, and 7 pi over 4. Ta-da-da! That was fun. Alright, so that is very comparable to what you're going to see on a test. I'm sure we posted the key for the rest of these questions. I'm going to skip around a little bit because we got to make sure that we're all confident on every type of question. Oh, number 14. Be careful and watch your signs because it does say that your angle's between pi and 3 pi over 2. So make sure, first of all, you're in the right quadrant. I'll be down here. Oh, what a lovely triangle. All right, and then it does say that your sine ratio is -4/5. So knowing that my opposite and hypotenuse are 4 and 5, and that, you know, think about signage, this is going moving downwards. Pythagorean theorem, or knowing that this is a triple, this would be a length of 3, but because it's left, I'm going to throw a negative down. I think there's even a big warning sign on your test that says, please watch your signs, and this is what we're talking about. Don't lose the fact that these are negative values. Now they want sine of 2 theta. I kind of crossed it off here. But sine of 2 theta is found by taking 2 times the sine of theta times the cosine of theta. And the signs will magically work themselves out on this formula, so don't panic. All right, so the sine of theta, we already knew that. That was a -4/5. And then the cosine of theta would be -3/5. Crank that all in the calculator or use the old noggin. Let's see, that's 24 up top and 25 in the denominator. So this comes out to a positive 24/25. All right, yes, I am skipping around a bit, but like I said, I'm sure you have a... Actually, I don't want to skip this next one. Cosine of 2 theta between 3 pi over 2 and 2 pi for the original angle. Cosine is 5/13, right? So adjacent and hypotenuse, 5/13. This side must be a 12 then, Pythagorean theorem, or you can just know it. But because it's moving downward, that's a negative, so watch your sign there. So for cosine 2 theta, my favorite formula is cosine squared minus sine squared for that identity. So you just got to watch your negatives in your parentheses. So cosine is 5/13 squared. This subtraction sign does not get squared away, so watch out for that. Sine is -12/13. Let's try to do a different color here. I don't know what this is, right? 25/169, and then a subtraction still exists, and this is 144/169, and yes, I know I should be able to do that in my head, and it turns out I can't. -119/169? I don't know. 145, yeah, I'm going to go with it. I'm going to say it's good enough, right? Okay, so you guys check and make fun of me when you find out I can't subtract. It's true, I can't. All right, so newer topic. We got our conic sections, although circles on their own is not a new topic at all. So the trickiest question, I think, for a circle is the endpoints of the diameter question. So first thing we need to do is find the center by using our midpoint formula. So we got x's, and to find the midpoint, you add them up and divide by 2. And then you do the same thing with your y's. You add them up and divide by 2. And then we end up with a center located at, let's see, 20/2 is 10. -28/2 is -14. So what y'all just found for me is your h and your k that goes into your circle formula. What we have to do now is find the radius And I think the easiest way to do that is just to like kind of plug it into the circle formula. So if you remember the circle formula, remember it's a derivation of Pythagorean theorem, which is distance formula, right? So some of you like thought of it as, oh, I'm just going to find radius squared by, you know, not square rooting Pythagorean theorem. Well, that's exactly what the circle formula is. So let's do that. You just got to pick your favorite ordered pair, which I don't really have one. But I'm going to choose one. I'm going to choose this ordered pair right here. So I'm going to say 12 and then minus h, which we just found to be a 10. And then the negative 16 minus, now we just found k to be a negative 14, so I'm going to do this double negative thing. And then watch what happens. It kind of just all works out. This is 2 squared, so that's a 4. Plus this is 2 squared, that's a 4. So it turns out our radius squared is 8. Now don't go further and find radius, because I really don't care about the radius. I just want to know the equation. So I'm going to go back to my circle formula, and I'm going to leave my x and y as variables. I'm going to plug in my center that I found a long time ago. And then the radius squared is 8. We just found that. So if you want to think of this as doing distance formula, but all the way until you take the square root, that's exactly what you are doing. I think some of us need to make that connection. All right, here's more circle questions. Maybe we'll do one of the completing the square ones. This is off of worksheet 2B. This is number 9. Completing the square, you got to do it twice though, because you have to do it for the x's and the y's, don't you? X squared minus 12x plus blank. And we do the same thing for the y's here. We got y squared plus 4y plus blank. That constant of 15 basically just needs to move to the other side. So I'm going to subtract the 15 over, but then I can't forget that I got to balance this equation out. So that blue and that green blank need to be added to both sides of the equation. So the blanks are found by taking whatever your middle term is, cutting it in half, the coefficient, and then squaring it. So negative 6 squared would be a 36. I think you've done 4,000 completing the squared questions by now, huh? All right, this cut in half is 2. 2 squared is 4. And then the factoring just is magically going to work itself out. Thank you, pattern. All right, this becomes x minus 6 quantity squared. This guy is a y plus 2 quantity squared. And then I can totally add, right? So that's 40 minus 15 is 25. You like my confidence there? Like 25? Alright. The other thing I'm going to have you do, just for funsies, is identify the center and the radius length. So the center is located, remember, built-in negatives on both of these, so 6 comma negative 2. And the radius length is the square root of this ending number, which is a 5. All right, there's another diameter question you can do for practice. I think that's probably the hardest one for kids, so please do practice that. And then our friend, the ellipse. So have your formula sheet handy, because he's going to be your new best friend on this question. Since I'm staring at it, let's do number 11 over here. This is x squared. Oh, I think this is from worksheet 11, by the way. So I'm flipping. Oh, I don't have my formula sheet in front of me. Good luck, Abruzzo. So for me, I need a combination of formulas and graph. So the first thing I find is center, because I'm very comfortable finding the center of all my conics. So 0, 2. And then I plot a center at 0, 2. Now, ellipses are a little tricky because the major and minor axes, you know, they can be flipped around because of the commutative property. So the major axis is whoever has the larger denominator. So this is the a squared value. This guy on the minor axis, this is the b squared value. So that tells me, if I square rooted them, a is 7 and b is 4. So in the, since that's under the x, in the the horizontal direction, I'm going to move 7 units. Boy, I always feel like I'm screwing something up when no one's there to tell me. All right, I know how you feel now, kids. All right, then our b value, which is in our minor axes, is vertical, so it's going up 1, 2, 3, 4, and down 1, 2, 3, 4. And then everyone gets a good laugh when Mrs. Abruzzo, oh, geez. Oh, gosh. Oh no. Oh, that's just the saddest ellipse I've ever seen in my life. Okay, so there you go. That's my ellipse. It's horrible. Let's talk about some other things I'm going to have you find. Now, I've already plotted them, but the locations I could easily find from the coordinate plane. But those of you who are major friends of formulas, I'm going to ask you to find the vertices and the co-vertices. But first, you need to know how to spell. Okay, so on this type of ellipse, which we refer to as a horizontal ellipse, the formula for the vertices is h plus and minus a comma k. So for us, that would be h, which was 0, plus and minus a, which is 7, comma k, which is 2. Now, you're better than this pre-calc. 0 plus 7, 0 minus 7, you can figure out. So you've got 7 comma 2 and negative 7 comma 2, which are exactly where I plotted them. So I'm feeling like I did something right. The co-vertices on a horizontal ellipse like this, the formula, which I'm using black ink here, is h comma k plus and minus b. So if I want to just straight up use my formula, that would be 0 comma, I'm using wrong color again, k, which is 2, and then plus and minus b, which was a 4. Again, pre-calc, you're better than this. So this is 0 comma 6 and 0 comma negative 2, which I didn't do a good job, but that is exactly what I tried to plot. So I'm feeling like I've done something really, really right. So that's great news. The other thing we're going to need to find are the location of the foci. So on a horizontal ellipse like this, the foci are located at h plus and minus c comma k. So for us, I never found c. All right, back up a minute, guys. The formula for c on an ellipse is the square root of a squared minus b squared. So for us, that would be, oh gosh, I gotta subtract again. Oh no. I feel like I screwed up something here. Story of my life, guys. All right, square root of 33, which, good news, that doesn't reduce. So h being 0, and then we're going to add and subtract the square root of 33, comma 2. So technically we're supposed to split that up, aren't we? We're supposed to say the square root of 33, comma 2, and negative square root of 33, comma 2. I'll be honest, Mrs. Abruzzo allows her kids to be really, really lazy on the foci part because they're usually icky radicals, and I just let them leave it just like this. Square root of 33 is 5 point something, so if I think about where that would be located, in each direction on the major axes, like roughly here and roughly here, which makes sense. It's within the football looking thing that I graphed. It's supposed to be an ellipse. Oh, good Lord, that's ugly. All right, 12 is a hoot. We have to complete the square, and it's a good time, man. All right, so let's look at the x's. First thing I notice is I can't complete the square with that 16 in front, so I'm going to have to factor out the 16 while I try to complete the square on the x's. So that becomes an x squared, and then this guy is a minus 2x, and then plus blank. Leave it alone for a minute. Don't jump the gun on that one. Plus, we're going to do the same thing for the y's, but I got to factor out a 25. This is one of those you just got to trust that it's going to work out. I promise it will. All right, y squared, unless you don't leave yourself enough room. All right, y squared minus 2y, because you factored out a 25, plus blank. And then this 359, it needs to take a hike, right? And I'm running out of room, so I'm just going to write 359 and then plus blank plus blank. Yes, that makes lots of sense. Okay, so this blank here is 1 squared is 1. However, it's really a 16. So this over here is a 16. And then again, this is a 1, but it's really a 25. Oh my gosh, I'm supposed to add that? All right, well, I did pass a few grades of math before, right? All right, so while I'm doing things here, I'm going to factor this into x minus 1 squared. keeping that coefficient out in front. I'm going to factor this into y minus 1 squared. This is where I'm going to bust out my best third grade math skills. All right, this is a 41. So if I added a 41 to that, that would be 400, right? Oh boy, now I'm in trouble. Because my next step is I have to come through and divide every single term by a 400 because this last number has to be a 1. Oh man. Where are you guys when I need you? Alright, I don't trust my math anymore, so I'm going to finally bunker down and get a calculator out. Here I go. That should frighten all of you that this is the first time I've touched a calculator today. Alright, so that's a 1 over 25. So this guy here becomes a 25. And then that's a 16, right? 25 over 400 is 16. Oh, ugly. Okay, y minus 1 squared. And then 400 over 400 is a 1, like it should be. So there is the equation for the ellipse. And then, wouldn't it be fun if we went and graphed it? And the answer is, sure would, Mrs. Abruzzo. All right, so the center is located at 1, 1. So I got that. Now for me, again, it's a combo of like a graphing approach along with a formulaic approach. The larger denominator is in the horizontal direction again. So on your test, it'll ask you for like the location of your vertices and your co-vertices. And I'm going to run out of room because I write too big. So in a horizontal ellipse like this, the larger direction, so the major axis is going square root of this, so 5 units in each direction. And in the vertical direction, it's going 4 units. So for me, I literally plot that, and then I make sure the formulas worked out the way they're supposed to work out. So here goes. Horizontally, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Co-vertices vertically, 1, 2, 3, 4. 1, 2, 3, 4. I stole that from the count. Oh, okay guys, here goes. This is almost circular. It's got such a lovely eccentricity. Oh man. Well, you know, it finished. No, it didn't. I thought it finished strong. It just is awful. Keep going. Our vertices. The formula for the major axis vertices on a horizontal ellipse is h plus and minus a comma k. And for co-vertices, that would be at h comma k plus and minus b. I already plotted them, so this shouldn't be a big mystery, guys. As long as I plotted properly, my 2 vertices on the major axis are at, I already forgot who A was. There we go, 5. So 1 plus 5 and 1 minus 5. So negative 4 comma 1 and 6 comma 1. That's exactly where I plotted them. Go me. For the co-vertices, it'd be a 1 comma, why did I make that so big? Try that again. All right, B is 4. So 1 plus 4 and 1 minus 4. So 1, negative 3, and 1 comma 5. I can't really see my graph anymore, but I think that is totally where I graphed them. Oh yeah, absolutely. Great job. And then for funsies, let's talk about foci. On a horizontal ellipse like this, your foci are located at h plus and minus c, comma k. Whoopsies. Once again, I forgot to find the value of c. So c on an ellipse is calculated by the square root of a squared minus b squared. So that'd be 25 minus 16. Oh man, that's nice, isn't it? That's the square root of 9, better known as 3. So our foci, oh, it's kind of bad news. That means I should give my teacher nice answers. 1 plus and minus 3, comma 1. So we got a foci at negative 2, comma 1. And this is so sloppy. All right, 4, comma 1. Boom and boom. Beautiful. Yeah. You know, the only other thing that would make this super fun is if we found eccentricity. So just for funsies, what if I wanted your eccentricity? Well, it's calculated by C over A. So the C value we just found to be a 3, and the A value is a 5. So this guy has an eccentricity of 3 over 5. Which, if you're looking for a decimal, is 0.6. There's a question on your test where you do have to know that. Oh boy, doesn't that look fun. Alright, this is probably, I don't know, this new stuff might be difficult for you, especially if you haven't done your homework, hint hint. They give you the center, the vertex along the major axis, and then a focus point. That's a little harder than what's actually on your test. What's on your test, I think, is a major axis question, so like, it gives you different information, I guess is my point. But that's okay, we got this. So we have an ellipse, and then we have a vertex. And here's what I notice. The thing that changes between the center and the major vertices, the vertices along the major axis, is that the x value changed to one of the vertices. So you can draw yourself a picture, but the other thing you might want to notice is that if the x's are changing, that means you have one of those horizontal ellipses, where this formula would have been from x plus or minus, nope, not that, h plus or minus a comma k. So that might be an easy way for you to figure out who your a value is, which is what we want to know. So from a 1 to a -4, you can set up the equation if you want, but 1 to -4 means that this a value is a 5. It's 5 units away. So I'm going to jot myself a little note here. A is 5. And because it's the horizontal one, this is going to be, the major axis is going to be with the x part of the ellipse. So let's talk about this ellipse. Center at 1, -3. I can write the part that kind of looks like a circle right away, right? And I know it's going to say equals 1. What I kind of figured out was with this guy having a major axis along in the x direction, and I just figured out that a is 5, that means down here you're going to have a 25, right? A squared. I feel like I didn't do a real good job of explaining why a was 5. What some of you are going to need to set up to get that number is you're going to have to say like, oh, -4 equals h, which is 1. And then you can either put down a plus sign or a minus sign as far as a goes, because you can figure it out. But if you subtract 1 over, you get -5. So adding a 5 and subtracting 5, it wouldn't matter because you got to go in both directions for the vertices. Anywho, I digress. Maybe you have no problem finding that out. Maybe it's a me thing. All right, let's talk about the foci. So for this style of ellipse, again, it's the horizontal one. The foci formula for that x part is h plus and minus c comma k. So here's what I'm noticing. If I had a 1 and then I added something to it and I got 4, that means that c must be a 3, right? 1 plus 3 would get you to a 4. And again, they're just giving you one of the foci and one of the vertices. So here's why we need that clue. C is not actually a portion of the formula, but you can calculate a or b based on the other guys plus c. So for an ellipse, c squared equals a squared minus b squared. So let's throw that information in. We got 9c squared equals a squared, which is 25. I feel like I messed something up here. See what it works out to. Alright, so subtracting 25 from both sides, you got -16 equals b squared. Oops, negative b squared. So the negatives end up canceling out. B squared equals 16. You can go as far as to tell me b is 4, but think about what I really want, guys. I want b squared because that's what goes right here in my formula. Okay, so I think I took the scenic route on that question. I think drawing a picture would have probably helped immensely. At the very least, I think kids would have been able to identify whether you had a vertical or a horizontal ellipse. Because if you're using the wrong formula, you're going to get really confused. These backwards questions where you got to build up the formula based on clues, I think are the hardest ones. So you've had plenty of questions that were assigned to you for homework. There's extras stuck in there on the worksheets that you could do for extra practice. The name of the game for you is going to be time. You got to pick a method that doesn't take you a year and a half to get the problem done, and you got to be able to get it done the first time you do it. And if you end up like trying it and then going, oh snap, I screwed something up, and having to redo the whole problem, you're going to be pretty upset. So I think everyone works better with a picture. Draw yourself a little sketch, figure out what you're working with. Getting your vocab and formulas down and being comfortable using them is really the hard part, in my opinion. I think the ellipses and circles will probably take you guys longer than the other part of the test. So approach your test however you want, but you should be able to get it done with plenty of time in the class. All right, good luck, everybody.